For today's lesson, we're going to be talking about descriptive statistics. Now, we're really just going to be talking about some basics, some mean, median, mode, things like that. Everything with statistics, however, starts with data. Here's some data. It's raw data. Now, it doesn't have any particular meaning at this point. It's just I chose a nice, pretty, clean, small sample so that we can work with. Now, this data, you'll notice 62, 45, 81, 67, etc. is not in order. I've gone ahead and ordered the data. There are things that we can do to data in its raw format, and there are things that to do it we must have an ordered format. Now, I'm going to be showing you a lot of manual ways, a lot of by hand methods. Some of these things are going to be very much review for you, some of them not so much. But in all cases, our goal here is to do them by hand so that when we apply technology to it, be it Minitab or graphing calculator, we understand what the calculator, what the technology is doing, so we now have an understanding of the concept. So, first things first, let's talk about mean, median, and mode. Mean, median, mode. Now, mode is super duper easy. Mode is the one that occurs most often. We talked about this when we talked a little bit about histograms, except when we talked in histograms we talked about how a group of data showing up most often. This we're looking for a specific point of data. Now, I only have 142, 145. Looking down the data, I have a couple 65s. So that's going to be my mode. Now in this case, it only does have one mode, making it unimodal. Now we have median. Well, median, if we think about it this way, if I were to talk to you about don't cross the median of a road, you're going to say, oh, don't go through the middle. Well, fair enough. Well, that's exactly what we're going to talk about here. We're going to talk about going right through the middle of the data. Now, to find the middle of the data, I have to put it in order. This is where ordered data comes into play. If I found the middle of this list of data, it would have no meaning because it is not in any sort of order. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 terms. That means the middle term is going to be term number 6. 1, 2, 3, 4, 5, 6. Okay. So this guy here is our median. Median. Now, that's easy because it was an odd number set of data. If there were 12 pieces of data, if I had an additional piece of data here, I'd have 6 on top, 6 on bottom. I would have to take the two middle terms and average them. In this case, they would have both been 65, making our job very easy. However, if they were different numbers, we would simply add them up, divide by 2, find the average or the mean between the two middle numbers. So that's your median. So that's going to be your middle number. Now, for your mean is your average. Anytime we talk about mean, we're going to be talking averages. Okay, now again, both of those are very broad terms, but in this case, we're talking about arithmetic mean. The arithmetic mean or average. Now, the way to do that is you simply add them all up, divide by how many there are. Now, if I were to add all of these up, I believe I come up with 700. And I divide it by 11, and I should get some sort of mean value. I can go to my calculator, pull it up here, and I could go through the manual process of adding them in. 42 plus 45 plus on and on and on and on. Get your total, then divide by however many terms you have. Alternatively, if you're a little bit more calculator abled, if I go to Stat, I can edit lists and put all my numbers into a list. You'll notice I did not put them in order. However, with the technology, it'll order them for us. So go ahead, put them all in here. 62, enter. 45, enter, etc. Anytime you're working with lists, you have to exit out. Now, using my calculator, I can find all sorts of things. But what I would like to do is I'd like to add all these up, and if I add them all up, they're going to come up to 700. So for my mean, the sum, we use sigma for sum, of all the values, these values we'll call them x, the sum of x equals 700. Now, I have 11 values, so I'm going to take the sum of x, divide it by the number of values that I have. We already talked about that as 11, so 700 divided by 11. 63.63. So our mean is 63.6363, so we could just 64 is fine in this case, or 63 repeat. Now, the symbol we use for this is x with a bar over it. X bar is the mean. So mean x bar, in our case, we have 63.64. That's going to be our average. So if we were to put all these together, my mean is 63.64, my median is 65, and my mode is also 65. Ideally, these numbers here should be very close if our data is balanced, if it's unimodal. This data, these three pieces, mean, median, and mode, are also called measures of center. Measures of center, because they're different ways to talk about where is the middle of the data. And they have slightly different ways of measuring where is the middle. Well, where would the mode be? Where is the highest bar on a histogram? It'd be in here. Where's the middle of our data? Well, it happens to be right here. Where's the numerical average? If each of the numbers have values, where's the numerical average? The answer is your mean right there. That is x bar. So, among the things that we need to examine is you take your observations, you add all your observations, divide how many observations you have. That's your x bar, that's your measure of center. Next, we need to talk about measures of spread. Now, a measure of spread is a little different idea. A measure of spread could be a number of things. Our easiest one is range. Range is nothing more than the max minus the min. How far is the top number from the bottom number? In our case, we take a look and we have 81 and 42. So we take 81 minus 42 and come up with our range. So we grab our little handy dandy calculator. 81 minus 42, 39. 39 is our range. That's a first measure of spread. It's a measure of how wide is the data put together. The other way to think about measures of spread would be if you had a basketball team. A basketball team, and a particularly professional basketball team, you're going to have a whole number of players, and they're all going to be fairly tall, so their measures of center are going to be fairly high. But you're also going to have them very tightly grouped, because all of the players, to play in the NBA, to play professionally, they all have to be tall, even the shortest guys, and so that measure of spread is going to be very small, versus if you just went and talked to any 25 people in the United States, you may have somebody very tall, you may have somebody very short, and so the average could even theoretically be the same, but they're much more spread out. So, a good way to think of measure of spread is how spread out the data is. Now, the other thing that we have is standard deviation, and we will come across that a little bit later. So, standard deviation. Now, while we're on this whole max-min thing, there is another way to talk about how wide your data is spread, or a good way to get a picture of your data. To do that, what we do is we do what's called the 5-number summary. The 5-number summary. Now, shockingly enough, there are 5 numbers in it, and given just those 5 numbers, you should be able to say quite a bit about the data. So the 5-number summary includes the min, which should be fairly easy to find. It includes the median, which we've already found. It includes the max, but it also includes two other points, Q1 and Q3. Now, the min of our data is very easy once it's in order to see that it's 42. The max is also easy to see, that's 81. The median we already found is 65. Now, in essence, we've found the bottom, the top, and the middle. So what we have is we have 50% of the data down below, 50% above. In our case, we have a middle number. We have 5 values below numerically and 5 values above numerically. So there's 5 on each side. Now, that's nice, but that only cuts the data in half. If we wanted to cut it a little further, we say let's do quarters. Quarters are fairly easy to do. So what I want to do is I want to take this half of the data and cut it in half. Now, different books have different ideas on how to do this. Some books would say if you have an odd number of terms, that you would exclude that value and find only the middle of the 5 upper values, in which case that would be easily 61. So you have 2 above, 2 below, 61 in the middle. That makes it Q1. Other books would say that if you have a value in the middle, you take it into account and you find of all 6 values. In that case, it would be 61.5 because I'd have 3, 3, and just like if we had an even number for median, we would take the average of the 2 values, so we'd have 61.5. Doesn't make a huge difference, that's why it's not something we really fight over. I personally eliminate the middle value, finding the middle of the top numbers. If anything, it broadens our data, broadens our spread out just a hair by eliminating that middle value, but rarely is it sufficient to make a difference. Now that means on the bottom of the data, 1, 2, 3, 4, 5, we come up with 71 is the halfway point of this bottom data. I have 2 on top, 2 on bottom, 71. We're going to call that Q3. Now obviously we call it Q3 because it separates the 1/4 of the data, 2/4 of the data, and in fact median could also be called Q2, 1/3 quarter of the data, and then the final quarter of the data. So 1, 2, 3, 4 groups of data. We'll come back in the next video and talk about what to do with those and use standard deviation to talk a little bit more about spread.